Good morning. We're going to talk today about the scientific process and how to create a good question. So this is the beginning of our new unit on how to design a scientific investigation. In the past, scientists have always considered the scientific process as a linear process where we went from step to step to step and that had a beginning and an end. What scientists have determined now is that it's really a cycle. An experiment begins, but the process of getting to the end is not linear and may take many different paths. As you look in the center, when a scientist encounters a problem, instead of starting over, they reflect and rethink. Notice that after reflecting and rethinking, the scientist can return or go to any part. So you can go to the middle, and then you can go back to the outside. So let's say something happens while you're developing your hypothesis and you realize it won't work. You can go in the middle, reflect and rethink, and then go back to your question or go back to the hypothesis or go continue on to plan and test. So today we're going to talk more tomorrow about observe and wonder. And an experiment usually begins with a scientist observes something and wonders why. Why did this? Why happened? Why does? Why are? So many times was. So today what I'm going to ask you to do if you're at home is to go to the video below that's also included, or the slideshow that's included, and watch this video without the sound. Okay? Just watch the fox without the sound and try to figure out what's happening. So I'm going to pause for a second so that you can do that. So go to the slideshow. It's on slide 6 and mute the sound and watch the video without the sound. Now I want you to think about 2 questions that you have about the fox video. Based on just what you saw, what do you want to know? What are 2 things that you want to know about that video? Write those questions or think about 2 questions if you're at home. So we can turn any of our observations or questions into a scientific experiment. We just have to take those questions and make them so that we have something to collect, some data to collect. So now I want you to watch the video again. So I'm going to ask you this time to watch it with sound and see if any of the questions that you came up with match with the experiment or explanation of what the fox is actually doing, because they collected some data. So if you go back and watch the video again, I'll pause so you can do that. So the scientific question should be testable and repeatable. So a testable question will allow you to collect data. So what did we come up with? Any questions that we could collect data on about the fox? Yeah, how often was the fox successful at catching a mouse? How often was he facing the certain direction? Did you notice anything else that they talked about in the video? A good question should be testable. There's data to collect and repeatable. So we can do it again and again. So look at the slide on the next question and think to yourself, is this a good question? So how does the type of soda I drink affect my heart rate? Do you think this is a good question or not? So think, is there something that we can measure? And is it testable? Can I collect data? And can I repeat it? So is this something that you could collect data on and repeat it? And the answer is yes. We could collect data and we could repeat this experiment. So which part could we collect data on? The type of soda or the heart rate? Those are the 2 things that are being changed or looked at in this video, or in this question. So we could change the type of soda and we could measure the heart rate. This question, why does my cat hate my mom? Is this a good question? What data could we collect? There's not any data to collect, and there's nothing we could really repeat, so this is not a good question. So we're going to spend some time looking at 4 different types of scientific questions. Questions are, you can look it up, that it's not testable, a good question but it's too hard, and then a scientific testable question. Is this a good scientific question? What are eggshell made of? What do you think? Drag your thumbs up or thumbs down here. This is not a testable or a good question because we can Google the answer. So if you think, well, I could Google the answer to that, it's not a testable question because we can already know the answer. The question has been answered with authority. The answer can be Googled or looked up. For example, what country are monarch butterflies found in? Somebody had to do that test originally, but now we can just type it in and look it up. How do plants grow? That is just something we would look up. Is this a good scientific question? Why did that bird fly away? Well, is it testable? No, it's not answerable. There are a whole bunch of reasons why the bird might fly away. You might have scared it. It might have seen food. It might have heard a noise. It might see prey or see a predator. There's all kinds of reasons, and we can't ask the bird, and we can't take data on that, so we can't. That's not a good question. So these are often, the not answerable questions are often why questions. May depend on a coincidence or an observation that can't be repeated. So why are there so many kinds of sparrows? We can't answer that. Why do so many people like that song? We can't answer that either. And those are things that are not answerable. The next type, is this a good scientific question? Do robins sing more often in the summer breeding season or the winter? Think about, is there something that you can measure? And is there something that you can change? And is it repeatable? So this is a good question, but it's really hard for us to do. We would need to have this running for years because we'd have to compare data in summer and winter. We would need to be able to probably follow the robins to where they go. So these are too hard for us. So a good question, but it's too hard. It's not possible for us to test. We don't have enough time. We don't have enough materials. We don't have enough money. We may not have enough education. Other questions like that might be, how does climate change affect the migration patterns of dragonflies? Well, that would be really interesting to know, but we don't have the resources to do that. Are the wildfires in the western United States affecting weather patterns in the eastern United States? Well, we can't test that either, but it's a really good question. So how about this question? How does the amount of fertilizer affect how tall the plant grows? Is this measurable? Can we collect data on it? Is it repeatable? Yep. So this is a good question. It has data we can collect. We have all the resources we need, and it's repeatable. So this is a testable question. So it's measurable, it's repeatable, and we have resources. Some other questions like that would be, which type of bird feeders do birds prefer, and does the amount of sunlight grass gets affect the time it takes to germinate? So a testable question is measurable, has something that can be changed, repeatable, and the resources are available. So we're going to talk briefly about something we'll be talking about more next week, but the thing that you change in an experiment is called the independent variable, and the thing that you measure is called the dependent variable. What makes a good testable question? It has something that you can change and something that you can measure. So here, in your question, what are you changing and what are you measuring? So would grass watered with 5 milliliters or 10 milliliters of water grow taller? Is this a good question? Yes, because there is something that we can change and something that we can measure. And so it is, again, changeable, measurable, repeatable, and we have the resources we need. So does the amount of fertilizer affect how tall the plant grows? Let's determine what is the independent variable and what's the dependent variable. So what would be changed about this? What would we be changing? Again, we would change the amount of water. So a question, this is also a good point where at the end of the scientific process we would do a little research. It's helpful to have background information about your topic. So we're going to talk more about that tomorrow, but this is the point where you would find out more before you move into your experiment, so you're not repeating someone else's experiment, or you might learn something where, oh, I don't need to do that, but I could do this in my experiment. Thanks for paying attention today, and have a wonderful day.